Good evening all. Today our discussion is on transient response of AC and DC networks. First of all, what is an transient response? Transient response describes how an AC or DC circuit's parameters like voltage or current changes when a sudden input is applied. You can write that definition here. Transient response, it describes how a DC or AC electrical circuit parameters like voltage and current changes over time after a sudden input is applied. Now, you can consider a circuit like this, a circuit with a switch and a resistive and inductive and capacitive network. The switch is closed at t is equal to 0th time. What is the behavior? This response explains the behavior of the circuit for voltage and current. It derives the equation of voltage and current, how these values will be changed over a time after a sudden input is applied. Sudden input is applied when this switch is closed. This is called a DC circuit. In DC circuit, transient response shows temporary behavior. When this happens, when the inductor and capacitor discharges or dissipates. In AC circuits, the transient response contains two terms. One is natural response or decaying transient, and one is steady state response. Why you have a doubt that why DC circuit have only one transient response and why AC circuits have two transient responses? Because transient response of DC circuit is the x of t is the response, then this is transient response, x of t plus x of steady state, as it is a constant. In the DC circuits, steady state response also exists, but it's purely a constant value. How is like the response will be like this. For first order, the response is the output responses like it shows like this. At steady state, this is the steady state. At the time of steady state, it attains a constant value and remains the same. At the time of switching, at the time of switching, it will be rising with an exponential form and goes to the steady state. So it only having it is necessary to discuss only on transient response, as the steady state is constant. So DC circuits will have only transient response analysis. Now transient response of AC circuit will have both transient plus steady state. These both are considered because transient responses decay after time constant, but the steady state response will be continuously flowing, because as the input is V of t will be Vm sin omega t, as the input oscillates throughout the circuit, so the steady state response also oscillates according to the input. So AC circuits will have both transient response and steady state response. Now these responses are classified based on the order of the differential equation. Those are first order circuits, these circuits contains either L or C, inductor or capacitor, not both. The combination are, one is RL circuit, resistive and inductive circuit, and resistive and capacitive circuit. For second order circuit, this circuit contains both L and C elements. The equation obtained will be in second order differential equation. the combination will be like RLC in series and parallel connection. Now first order circuits. First one will be RL circuit. We will discuss with source. So let's draw the circuit diagram. This switch will be closed at t is equal to 0th time. Initial current of the inductor is 0. The switch is connected only at t is equal to t greater than 0. So the switch is ideal. It is circuit closed at t is equal to 0. So now applying KVL here. Then minus V, the current direction is this way, and the voltage polarities are given here. When we start from here, we will take the first sign here, plus R into, we will consider I of t, then it is I of t, plus L into, we know the drop across inductor will be L di by dt is equal to 0. So we will do R, we will put this V in LHS, L di by dt is equal to V. Now we divide R by R on both sides. I of t is equal to L by R, di of t by dt is equal to V by R. Now we will interchange this. We will take I that side, L by R, di by dt by dt, V by R minus I of t. Now we will put all I of t's in one side and remaining terms in other side. To do that, we will first take I of t that side, L by R, I of t by dt is equal to V by R minus I of t. Now we will take I of t, these are all I of t terms, we will move this side, and remaining L by R into dt we will put that side. So di of t by di of t will be remaining same, and V by R minus I of t will be coming down. And when this term goes this side, R will be in the numerator, L will be in the denominator, R by L, and dt will come to numerator, dt. Now applying integration on both sides, we have a standard formula that integration of 1 by 1 minus x dx is equal to ln of 1 minus x plus c. So with that formula we will apply the same integration here, integration 1 by V by R minus I of t di of t is equal to R by L dt. Now it will be, it's minus, so minus of ln v by r minus I of t is equal to r by l, as integration of constant is t, plus k. K is the arbitrary constant. Arbitrary. Now to find the value of k, let's take at the instant t is equal to 0. So at t is equal to 0, minus ln of v by r minus I of 0 is equal to r by l of 0 plus k. We considered at initially the switch is closed at t is equal to 0, so before that I of 0 will be 0 itself. So minus ln of v by r or else I will write here minus ln of v by r is equal to k. That means k is equal to minus ln of v by r. Let's consider this is equation 2 and let's take this is equation 1. So placing equation 2 in equation 1, so minus ln of v by r minus I of t is equal to r by l into t minus ln of v by r. Putting all logarithms in one side and other terms in RHS, so r by l, we are taking this term to RHS, LHS, r by l, this term is going this side, so this minus will be become positive, ln of v by r minus I of t minus ln of v by r. So now r by l of t, here we can write log a minus b, log b is equal to log ln of a by b. We can write in this way. So we will write this as ln of v by r minus I of t by v by r, r by l into t. When this natural logarithm ln is come to this side, as this term, positive term is moved to LHS, it will be negatively assigned. When ln goes this side, then it becomes e power minus r by l of t is equal to, when we divide this v by r, it will be 1 minus r by and it is in denominator, or we will move this v by r to this side. We will write as it is v by r minus I of t by v by r. Here this v by r goes to that side, and our aim is to put this in LHS and remaining all terms in RHS. So v by r e power minus r by l of t is equal to v by r minus of I of t. I of t will be put in the LHS, remaining terms in RHS. So I of t will be v by r minus v by r e power minus r by l of t. let us take tau is equal to L by R and rewrite the equation. I of t is equal to V by R minus V by R e power minus 1 by tau of t. That means tau is L by R. If L by R is reciprocal of R by L, when this R is written in here, then it will be 1 by R. So it is totally written as tau. So if we put in if we consider t is equal to instances like tau, 2 tau, 3 tau, then the waveform we will see like this. This is total V by R, and at first time constant, that is tau, it will be 2 tau, and it will be 4 tau, it will be 6 tau. This is 0.632 times of V by R. At first time constant, it reaches almost 63% of the value. At fourth time constant, it reaches up to 99% of the value, 99.81% of the value. So at t tends to infinity, the circuit will go to steady state. Now we got I of t. Now let us find voltage across the inductor and voltage across the resistor. So we will draw the circuit. So voltage at the inductor will be VL of t is equal to L di of t by dt. We got I of t as d by dt. I of t is V by R minus V by R e power minus R by L of t. So if we differentiate it, the differentiation of constant is 0. So minus V by R into minus R by L e power minus R by L of t. R will be cancelled. When this multiplied inside, this L and this L will be cancelled out. Minus into minus plus. So V into e power minus R by L of t is voltage across the inductor. For this, the voltage waveform will looks like 0 voltage across the inductor. When the time increasing, the value will be starting from V and decreasing to 0. This is the value, this is the waveform of the circuit. And finding VR of t. VR is equal to I of t into resistance. I of t is, we know, V by R minus V by R e power minus R by L of t into R. When we multiply R, this both will be cancelled out, and if we take it common, 1 minus e power minus R by L of t. So from this it is clear that at 0 value will be 1 minus 1 0, so it will be VR will starting at 0th point and rising like this. if this circuit having a initial current I0, then if initial current in inductor exists, then equation can be written as I of t is equal to V by R minus I0 e power minus R by L of t. It is the final value. This is also the final value, and it is the initial value, and it is the decaying coefficients. So standard equation can be written as E is equal to V by R. If you consider here plus, then if you multiply minus into inside, then I0 minus V by R e power minus R by L of t. That is final value plus initial minus final into decaying coefficient I of t. This is the standard equation to solve any problem in this circuit, in first order circuit. The output, if there exists an initial current, then the current waveform look like this. I of t, initial value is I0, and it will goes up to V by R, final value. So it will goes like this at time t. For a source free or without source, the circuit will be looks like this. At t equal to 0, it will be closed. Initially switch is closed at A. So after t equal to 0, switch is closed to B. The circuit looks like this. Now an initial current I of t will be flowing. Let's consider it having initial current I0. So writing the applying KVL in the circuit. For this circuit, starting from here, it's positive, negative, positive, negative. So R I of t plus L into d I of t by dt is equal to 0. Now all considering that V by R of di of t by dt is equal to 0. Putting all I of t terms in one side, remaining terms in other side. That is looks like I of t is equal to minus L by R di of t by dt, and putting this taking this I of t here and remaining terms this side, that will be r, it will be reciprocal, r by l dt is equal to minus 1 by I of t di of t. So now integrating on both sides, it will look like integration of r by l dt is equal to minus integration 1 by I of t di of t. After integration, r by l of t plus k is equal to minus ln of I of t plus k. Let's now at k we already written here, no need to write here. So at t equal to 0, r by l of 0 plus k is equal to minus ln of I of 0. We know I of 0 will be I naught, as there is an I naught initial current. So k is equal to minus ln of I naught. Placing the this considered as 2, this considered as one equation, putting the k value inside, r by l of t minus ln of I naught is equal to minus ln of I of t. So we are considering I of t is in one side, so we are putting this into LHS and remaining terms that side. So positive ln of I of t minus ln of I of t is equal to minus r by l of t. So from logarithm we can write this as I of t by I naught is equal to e power minus r by l of t. I of t is equal to I naught e power minus r by l of t. So for this, the output graph is look like this is I naught, and it will be in a decreasing form. It is tau, 2 tau, 3 tau, so on t. So this point will be 0.368 times of I naught. At t tends to infinity, I naught will be equals to 0. Let us write voltage equation for the circuit. As there is a source free, we can short it as like this. So I naught is flowing here, then VL of t is equal to L di of t by dt. The I expression we got is L di by dt I naught e power minus r by L of t. Now differentiating I naught into minus r by L into e power minus r by L into t. So LL will be cancelled out. The final expression will be I naught into r minus e power minus r by L of t. So the voltage polarity is negative. It indicates that this is the drop across the resistor. I naught into r is the drop across this resistor. So we can consider this as V. So VL of t is equal to minus V times of e power minus r by L of t. This is the equation. The waveforms look like, as it is a negatively signed, so minus V it will be in the decreasing form. So we can consider, we can look this as the polarity will be, if we will be reversed. Before, when the source is existing, the polarity will be, positive polarity will be top and negative will be down. When in the dissipating, when the source is not there, then the polarity will be changing, but the current polarity or the current direction will be as it is in the both cases. With source and without source, the current direction is same, but the voltage polarity will be changing. In this question, we need to find I of t. So at t is equal to 0, the switch is opened. At t minus, that is before opening the switch, that is closed. So we will redraw that circuit. So we are finding, first we are need to find the initial current I0 by closing that circuit. As a steady state, the inductor will be short circuit. So 10 volts applied here, 4 ohms, 30 volts and 1 ohm and a short circuit current. This is considered as I0. So as there is a short circuit across this source, the current coming from this will circulate in this direction. The I0 comes from here and passes through this short circuit. The current will be I, that is we consider it as I1. If it is I1, it is the resultant of I0 and the current I2. So this will be the I0 current and it will be closing the circuit. So the current I2 will be flowing in this positive, negative and positive, negative. If we apply KVL here, minus 10 and it is plus 4 I2 minus 30 plus 1 I0 is equal to 0. So this will be 4 I2 plus I0 is equal to 10. So from this short circuit path, we can tell I2 will be, if you apply KVL here, across this loop, then starting from this point, 4 I2. So in this I2 will be 30 by 4. We got I2 is equal to 30 by 4. Substituting this value in this equation, so 4 is equal to 30 by 4 plus I0 is equal to 40. 4 cancel. I0 is equal to 40 minus 30. I0 will be 10 amps. Now finding IL after switch opened. Redrawing this circuit. As it is a steady state, after switch it's a long time happened, so short circuit, then IL 1 amp, 4 ohms and 30 volts, 10 volts. So IL is flowing in this direction. As it is a series connection, current is same, so we will apply a KVL here, minus 10 plus 4 IL minus 30 plus IL is equal to 0. So 5 IL is equal to 40. IL is equal to 40 by 5, that is 8 amps. So from this we can write the current equation. I of t is equal to final value plus final value minus initial value into e power minus r by l into t. We get final value as 8 amps, initial value as 10 amps. So we need to find R and L from this circuit. So from this circuit, R will be RTH. As the Thevenins, we know how to calculate the Thevenins by short circuiting all voltage sources. So this is 4 ohms, this is 1 ohm. RTH, as RTH it is 1 plus 4, it is 5 ohms. L is as it is from the question, it is 0.5 Henry. So we will rewrite the question solution as I of t is final value is 8 plus 8 minus initial value is 10 amps e power minus 5 by 0.5 into t. This is the final value. Now we will write as 8 minus 2 e power. If you cancel this out, it will be minus 10 of t. Now our answer is here from the question. Our answer is sorry, it is not final. Here it is will be the initial and here is the final. So the value will be plus. So the answer is A.